Number 28, in figure 4.14, a stone is projected at a cliff of height 8 with an initial speed of 42 meter per second. So we will have PO here is 42. So PO is 42 meter per second. Directed at angle theta 0 is equal to 60 degrees. So I'll have 60 degrees here. Good. Above the horizontal, the stone strikes at A 5.5 seconds after launching. Okay, so it strikes this here at T is equal to 5.5 seconds. Good. And then the question is find the height edge of the cliff, the speed of the stone just before the impact at A, and see the maximum height edge reached above the ground. Okay, so we have to decompose this initial velocity into vertical and horizontal component here. We have the vertical, the horizontal speed here is VO, x. But VO, x there is VO cosine of theta. So I'll have cosine of theta 0. And that will be 42 cosine of 60 degrees. And that will be, okay, let's use calculator. So we will have 42 cosine 60. We will have 21 meter per second. Okay, and we also have the vertical initial velocity, which is VO, y. Okay, so we will have VO, y here is VO sine of theta 0. Which is 42 sine of 60 degrees. And that will be, okay, what is 42 sine 60? We will have 36.37, okay, 36.37, and the unit here will be meter over second. Good. We now have the initial velocity, and in the maximum here, in the maximum height here, we still have this VO, x, right? So we will have this Vx here is equal to the initial. So this one will be 21 meter over second because the horizontal velocity is constant. But then in the vertical one here, we have this Vy here is equal to 0, right? Because it stopped moving up. It start moving down, right? So here we will have the vertical velocity is 0 meter per second. Okay. Now let's analyze when the projectile is going up. So when it is going up. Okay, we will have here Vy squared is equal to the initial vertical velocity, which is Vo, y squared plus 2, and then times the acceleration multiplied by the here maximum height, right? So we will have h here. Okay, and let's plug this in. So we will have this velocity in the maximum height is 0, so have 0 squared, and then the initial velocity vertical one is 36.37 squared, and then we will have the only acceleration that works in this system, which is gravity, right? But it's slowing down the projectile, so I will have negative here. So I have minus 2, and the acceleration here is equal to 9.8. And we have this h here. Good. Now, what can we do is just isolate this h, right? So we'll have 8 here is equal to 36.37 squared divided by 2 multiplied by 9.8. And nothing that we can do except plug this into calculator, right? So we will have 36.37 squared divided by 2 multiplied by 9.8. And that will equal to 67.49. So we'll have 67.49. And the unit here will be in meter, right? So we will have that one here. Good. And then I think we can calculate also the time, right? So we will have Vy here is equal to Vo, comma y, and then plus 80, right? So we will have this is equal to 0. Good. And then the initial velocity here is 36.37. And then plus this one here, the acceleration, remember that we have minus 9.8. Then multiply it by the time. So we will have the time here is equal to 36.37 divided by 9.8. And that will equal to, we will have 36.37 divided by 9.8. Good. And we will have 3.71. So we will have 3.71 here, 3.71 second going up. So this time here, when it is going up, is equal to 3.71. But from here, we can calculate the time when it is going down, right? So we have t going down here. Why? Because we know the total time is 5.5, right? 5.5 is the total time. So the time when it is going down, so let's write that. So the time when it is going down is 5.5 minus 3.71. And that will equal to 5.50 minus 3.71. And we will have 1.79. Okay, 1.79 second. Good. Okay, let's save that. So we will have the time when it is going down, which is 1.79 second. Okay. And we already get the answer for the C, right? So the maximum height is 67.49. So let's save that and let's work on the other question. Okay, let's calculate this. Okay, so far we only get the answer of question C, and we need to find out the question A and B. Okay, we need to find out this small h here. We already find the capital H, so we need to find out that, right? So here, when it is going down, we need to analyze when it is going down. Okay, when it is going down, we have it is free falling, right? So we will have the vertical velocity starting at 0. So have free fall motion in the vertical direction. Okay, and we can have this height here. I will name this as delta H, right? So we will have delta H there. Remember that this is a free fall, so I can calculate this height here is 1/2 gt squared, right? So we know that the gravity there is 9.8, okay, 9.8, but then the time here is 1.79, so we'll have 1.79, and it is squared. So we will have that delta H here is equal to, okay, let's plug that into calculator. So we will have 1/2 multiplied by 9.8 multiplied by 1.79 squared, right? So I'll have 15.7. Okay, so I have 15.7, and the unit here will be in meter. But remember that delta H here is capital H minus small letter h. So we'll have that equal to 15.7. But we know that this is the capital H, so we'll have 67.49. and minus 8, that will equal to 15.7. So we know that this 8 is equal to 67.49 minus 15.7. And that will be, what is our 8? So I will have 67.49 minus 15.7. Okay, so I'll have 51.79. 51.79, and the unit here will be in meter. And this is the answer for question A. Good. And now what is the speed just before it's touched the ground here? So remember that the horizontal velocity here is equal to initial velocity. So I will have this one here. Vx is still 21, right? So I have 21 meter over second. And the problem is we need to find out what is this one here, which is Vyf, or for final. So Vyf, I think we can calculate that, right? So for question B here, we can calculate Vy final, and that will equal to Vo plus Gt, right? So we will have G multiplied by T. But initially it is 0 here, so we will have this equal to 0. And we know that G there is 9.8, and the time when it is going down is 1.79. So I have 1.79. And so for the Vy final here, that will be 9.8 times 1.79. 1.79. And that will be 17.54. 17.54. But remember, this is the vertical velocity. To get the total speed, we need to get the Pythagorean theorem here. So I'll have P here is equal to the square root of Vx. So we'll have 21 squared, and then plus this one here, 17.54 squared. Okay, and that will be our final answer for question B. What is it? So let's calculate that. 21 squared plus 17.54 squared. And I will have 27.36. 27.36. And the unit here will be meter over second. And here we have all the answer. This is for the maximum height. And then this is the cliff height. So we will have this as question A. And for question B, the speed of the stone just before reaching the ground is this one here. Okay, hopefully I did not make any mistakes during my calculation. Thank you for watching and see you in the next video. Bye bye.